Yes, good morning children. Now let's move further with the next type of chemical reaction that Rx shows. We saw about nucleophilic substitution in the previous class. Now let's move further. What other reactions does it show? The next is wurtz reaction, a very important reaction where two molecules of alkyl halides in the presence of sodium and dry ether gives you an alkane. Okay, so you start with, say, methyl chloride, you will get ethane as the product. Now what is more important about wurtz reaction is it is not preferred if two different Rx molecules are taken. Like if you take, say, methyl chloride and ethyl chloride, then you may expect propane to be formed. But then in the medium, when methyl chloride and ethyl chloride are there, it is possible that one methyl chloride may come in contact with another methyl chloride molecule in the same medium, giving rise to ethane. Same way, ethyl chloride coming in contact with ethyl chloride giving rise to butane. With the result, what happens? A mixture of three products are formed, propane, ethane and butane, and yield of any one is poor. That is why wurtz reaction is not preferred if you take two different kinds of Rx molecules. Okay, and it can also be not used to prepare methane. Single carbon cannot be prepared because you get double the number of carbon atoms from where you start. Then you have the next property in the formation of Grignard reagent. It is such an important reagent which is used in organic synthesis. Now Grignard reagent, what is it? It is alkyl magnesium halide. So it is Rx treated with magnesium and dry ether, you get Grignard reagent. Now this Grignard reagent has to be preserved in the absence of moisture in a moisture proof container because it will react with water giving rise to alkane. Okay, see the reaction there, with water it will give alkane. Now come to the next one, that is again a very important reaction, beta elimination. That is reaction with alcoholic KOH. Alkyl halide, when it is subjected to alcoholic KOH treatment, it will give you an alkene. Now this is called as beta elimination. Why it is called beta elimination? Because the carbon holding the halogen is called alpha carbon and the adjacent carbon is called as beta carbon. So halogen from alpha carbon and hydrogen from beta carbon, it gets eliminated as HBr. Okay, and that HBr will react with KOH giving you KBr and water. So it is called beta elimination. That is, hydrogen from beta carbon is lost. That is why it is called beta elimination. Now in this case, there is only one beta carbon. But you see this example, this is the carbon holding halogen, so it is alpha, and you have on adjacent positions two beta carbon. Okay, so it could be this hydrogen from beta carbon going away with Br, or it could be this. So here you will get propene as the product. Okay, now this is a symmetrical alkyl halide. So the hydrogen could go from either here or from here. So you will get propene. So double bond, whether it is between these two or between these two, it is going to be propene only. But then if your molecule is like this, now here alpha carbon you are shown, and on one side you are having only one beta carbon and on the other side you are having one beta carbon followed by another gamma carbon. Is it not? Alpha, beta, gamma. So the chain length is different on either side of alpha carbon. So in such a case, which will be the major product? Whether hydrogen from this beta carbon will go or from this it will go. Now if it goes from here, then you will get a double bond between alpha and beta. And if it goes from here, then you would be getting a double bond between these two. Right? Now the hydrogen from here will be lost to give you a symmetrical alkene, that is but2-ene. Whereas if the hydrogen from here is lost, then you will get but1-ene, which is unsymmetrical. Okay. And in this particular reaction, only a symmetrical product is the major product. And this is what is given by Zaitsev rule. Okay. Now, in simple terms, if you want to understand Zaitsev rule, or you want to identify the product, then you can take this concept. See, out of these two beta carbon atoms, this beta is having only 2 hydrogen, this beta is having 3. So this beta carbon is comparatively poor with respect to the number of hydrogen it holds. Okay. So they say poor becomes poorer. Jis carbon ke paas kam hydrogen hai, that will become even less. Okay. So you say poor becomes poorer. And also symmetrical alkene is the major product. That is another indication to identify your product, whether you have identified correctly or not. Now, let us see more examples, because it's a very, very important reaction. This is question number 10 of your exercise as well. Now, this is a cyclohexane group holding on to Br and a CH3 group. Okay. Now, this is the carbon which is alpha holding the bromine, and outside the ring there is a beta carbon, and inside the ring also there is a ring in the beta carbon. Okay. Now, from which carbon, whether from this carbon or from this carbon, the hydrogen would be lost. Okay. If it is lost, then you will get a double bond outside the ring like this. And if the hydrogen from inside the ring, that is lost, then you will get a double bond inside the ring like this. And so here you will find this is more symmetrical. Why I say? Because you have, see, there is conjugation. Single bond here, then a double bond, then a single bond. Either you take this way or you take this way. It is conjugation in the molecule. So that is the major product. Some kind of symmetry is there. So this is the major product and this is obtained. Now supposing if you have this kind of a compound, again here this carbon is having less hydrogen, this carbon is having more hydrogen. So the double bond will be formed between these two. So this is the major product, right? Same way if you are having this compound, now you are having less number of hydrogen with this beta carbon, then this is also beta, this is also beta, but this beta is not having any hydrogen, this beta is having hydrogen, but the hydrogen from here will not be lost because the double bond will be in the branch, is it not? It will not hold good. So here this is the major product. If this hydrogen is lost, then you will have double bond here, right? So what you have to identify here is more highly alkylated alkene is the major product. More highly alkylated. Double bonded carbon के साथ एक methyl है और इस double bonded carbon के साथ this is one methyl and this is another alkyl group. There are two alkyl groups, one methyl and one terbutyl. And here you are having one methyl. Whereas if you consider this, then this double bonded carbon is having just hydrogen. There is no alkylation at all, right? With the result, this is not the major product. This is the major product.